Hello, this is Mr. Snyder, and today's lectures over igneous rocks and intrusive activity. We're going to be looking at an introduction to igneous rocks and their landscapes. Okay, so whenever you start talking about rocks, there are basically three types. You have what are called igneous rocks, sedimentary, and metamorphic rocks. And all of these rocks are subject to processes that change from one rock type into another. Of course, whenever you start talking about changing one rock type into another, you're of course talking about the rock cycle. Well, and the rock cycle has been attributed to James Hutton, of course, the father of modern geology. Okay, well, with this, what you can see is there are several different processes that go into making the three different types of rocks. So we're going to cover the rock cycle here just really quickly to make sure that you understand those processes. All right, where do we start? Well, let's start right here. First thing that you're going to notice is whenever you start looking at igneous rocks, of course, igneous rocks form either from magma or from lava. Now, the primary difference we'll talk about here in a second, but the thing that I really want to stress is the process of cooling and crystallization. Okay? So with this cooling and crystallization, that actually takes and makes igneous rock. So igneous rocks come from magma or lava. Now, once you take those igneous rocks and expose them there at the surface, they of course can be weathered and broken down, and then that weathering is going to make sediment, and then that sediment is going to be transported and deposited, and then you're going to go and lay that thing down, and then the next process is lithification, as you can see in the bottom right-hand part of the screen. So we've got two processes so far: lithification, the process of making sedimentary rock, and crystallization, the process of making igneous rock. Well, if you start looking at our third rock type is, of course, the metamorphic rock. Now, what's unique about metamorphic rock is metamorphic rock has to come from a pre-existing rock. You have to take and physically alter that rock through heat, pressure, or chemically active fluids. So whenever you start to look at these different rock types, it's really going to be beneficial to you to know how these rocks form. So again, we start looking at the cooling and crystallization process, which makes igneous rocks, the lithification process, which makes sedimentary rocks, and then the metamorphic process that makes metamorphic rock. Now, as you can see from the rock cycle itself, you can see that we can go through the middle, we can go anywhere. So the thing that I want you to know from this is any type of rock can make any type of other rock, or it can make itself over again. Yes, you can take a metamorphic rock and make it a different metamorphic rock. Yes, you can take an igneous rock and make another igneous rock just through the process of melting. So make sure that you have a good understanding and look at this to see exactly what goes on with the rock cycle. All right, where we're going to begin, of course, with igneous rocks is understanding the formation of magma. Okay? Now, whenever you start talking about magma and lava, magma is merely molten rock that basically is found beneath the surface, whereas lava is molten material that is actually found upon the surface. So whenever you start differentiating igneous rocks, and you're going to understand this after in the next few lectures, a igneous rock that forms from lava is actually going to be somewhat different than an igneous rock that forms from magma. Okay? Now, whenever you start talking about this liquidous material or this magma, what you have to realize is magma does consist of three parts. Of course, it consists of the liquid part called the melt. It consists of the solid part, which are the crystallized minerals. And then, of course, it consists of the gaseous component called volatiles. So whenever you start looking at this, you're looking at there are three major components of magma. So whenever we start asking ourselves, okay, what conditions are actually needed, or what conditions influence the origins of magma that basically form these igneous rocks? Well, as you can see here, there are four primary factors that influence: temperature, pressure, volatile content, gases, specifically water content, and composition. Okay? So whenever you start looking at this, one of the first things that's kind of the simplest thing to explain with the origins of magma is that temperature. Okay, I mean, we're just going to look at temperature, because as you go deeper into the Earth's crust, as you can see over here, you're going down deeper. You're going to basically increase temperature as well as pressure. Now, we'll get to pressure here in a second. But one thing that you have to look at is what goes on. How does basically going deep into the Earth's crust influence the formation of magma? All right, so here's one of the first things we have to look at. Looking up here, let's focus on the concept of just temperature itself. Whenever you take and increase the temperature of a solid rock, so you're taking and let's say we subduct that. So in other words, we have a convergent boundary where two plates are coming together and solid rock is being pulled down or pushed down underneath and going deeper in the crust. Well, as you actually increase that temperature, as you can see right here, what's going to end up happening